Hi everybody, welcome to week 2, term 4, lesson 1 for year 6 maths on a Monday. This week it's all about my favorite topic, which is data, and we're looking at interpreting secondary data today. Secondary data is data that somebody else has put together. So compared to when you do a survey yourself or you gather some data and put it into a table or a graph, this is data that you might see on a website, in the news, anywhere else. Data that you basically haven't put together yourself is secondary data. So today we are learning to interpret different data displays we find in the media and in factual texts. Now, data displays really just means any way of showing or displaying data. Now, so far we've looked at tables and we've also looked at column and line graphs. So that's the first success criteria for today, is to be able to identify those. And we're going to look at some examples in a moment. They're just different ways of showing or communicating data. Then we're going to be looking at describing the shape of the data. Now, this isn't so relevant for tables because tables just tend to be a whole lot of numbers, but more so with column and particularly with line graphs, sometimes it forms a shape that we can sort of draw some kind of conclusion about, or it kind of tells us something about the data. The next thing we're going to be doing is recognizing trends. Now, this is kind of related to the shape as well. And it's particularly related to data that's shown over time. What is the trend over time? Is something increasing? Is something decreasing? Is it, does it go up, then go down, then up and down? Is there some kind of pattern or trend? And lastly, the most important part of today's lesson is about reaching a conclusion about the data. This is what kind of summary statement or overall statement does the data tell us? Whether we're looking at population data, looking at sports results, looking at environmental data, what story does it tell us about what's going on? Okay, let's get into it. Okay, so I've been given this data display, and I first recognize that it's a line graph. So it's not a column graph because it doesn't have columns, and it's not a table because it's not set into rows and columns with numbers. It's a line graph, nice and simple. The next thing I want to look at is what's the heading? What's the title of this graph? It tells me this is population growth of Australian capital cities since 1971. Okay, so now I know what this data is about. I'm going to look at how they've decided to record or show this data. So I'm going to look at the y-axis first. And instead of just giving me numbers, so saying, you know, this many 100,000 people, it's actually given me percentages. So this percentage is telling me this is a percentage growth from the starting point in 1971. The following year, how many people moved to that city, or how many people were born in that city, and what was the percentage of that based on the previous year. So it's using the original population from 1971 and measuring growth as a percentage of the original population. So that's what I can see here on the y-axis. Then I want to look at my x-axis. So I can see that this is happening over time. I've got my starting point here, which will be 1971. Then I've got 1975, 1985, sorry, 1975, 1980, 1985, 1990. So it's going ahead in the increments of 5 years, but everything that happens between these, there'll be those kind of in-between years, so 1976, 1977, etc. Okay, all right, so now I figured out what my y and my x-axis is telling me. Now I want to see what data they're plotting on here. So I can see I've got different colors for each of the capital cities. I've got Darwin, Perth, Canberra, Brisbane, etc. Also, the last thing I want to check out, which is not so important for today, but will be important later on in the week, is knowing what the source of this is. Now, this is from this website, chartingtransport.com. It's kind of like this transport nerd who kind of goes through different transport data, but he's looking at the growth of these cities, and he actually tells us that this data is taken from the Australian Bureau of Statistics. So it's a pretty reliable source of data. Okay, so let's look at, we know what kind of graph it is. Now I'm going to look at the shape of the data. So I can see here, it's kind of going up for each of these cities, it's increasing. So the percentage is increasing over time, and that's the case for all of them. Now, some of them are a bit steeper than others. So that means it's increasing faster, or by by a greater percent than those other cities. Now I want to look at my top one, which is Darwin. And I can see Darwin is kind of the winner in the sense that by, I think it's 2017, I think this data is, or 2019, it's grown from its 1971 population, it's grown by 250%. So it's not only doubled, it's almost tripled in size. So it's grown by 2.5 times that city. Then I can see Perth here. Perth, if I line it up, it's greater than 150%. And then my other kind of cluster of cities down here, they're around about the 50% mark. Some are less, like Adelaide and Hobart, and some like Melbourne and Sydney are slightly above, but less than 100%. Okay, so I can see all of my cities have increased over time. Now let's look at this one with Darwin here. Darwin's a little bit different because it kind of goes up here and then suddenly it drops down very quickly in 1975. Now you might be like, what happened in that year? Why did the population just stop growing in that year all of a sudden? And then again, it kind of kicked up again in the 1980s. Well, actually in that year, at the end of 1974 on Christmas Day, there was a huge cyclone in Darwin known as Cyclone Tracy. It was quite devastating. It ruined a lot of the city. I think 71 people died. So it would have probably deterred people from moving to Darwin for quite a while the city was still recovering. Some people might have even left. The other thing I need to note about this data, and this is what the data doesn't tell me, but this is what I know as background information, is that each of these cities are all different sizes. They're not all the same size. And so a smaller city is going to have even just a few people moving to a smaller city is going to increase its population more than, as a percentage of its original population, than a larger city. So these larger cities like Sydney and Melbourne, they're Australia's two largest cities, are going to need quite a lot of people to move there for them to change the starting population as a proportion of that population. Compared to Darwin, which is already back in 1971 is very small city. We're talking about a couple of 100,000 people, not big compared to Sydney, and Melbourne, which were about 3 million at that time. So even just a couple of thousand people is going to have a greater impact than Melbourne and Sydney. So that's the other thing to note. So these cities here, Brisbane, Canberra, Perth, and Darwin, they're smaller, considerably smaller than Melbourne and Sydney. Okay. Now that we've looked at the shape of the data, we've kind of interpreted it and figured out what it's telling us. Well, not so much what it's telling us. What are some of the main findings or statements I can say about this data and about Australian capital cities and their growth? Well, firstly, I can say that since 1971, Darwin has experienced the greatest population increase as a percentage of its 1971 population. So it was pretty much over the whole time, it's kind of been on the top city for population growth. Perth, Canberra, and Brisbane have had similar rates of growth. Now, they haven't been the same. They're not exactly the same, but I'd say they kind of ended up fairly similar positions, and they've all kind of tracked pretty kind of evenly compared to one another. Since 1995, Darwin has had the slowest rate of growth. So the lower the percentage means that the population of that city isn't growing as quick as some of these other cities. And I can see Hobart here is the yellow one. So since about 1995, when they're all kind of connected, suddenly it just started to kind of drop off and go along here, and it's tracking along the bottom. And then it's followed by Adelaide. Adelaide is the second slowest growing city, according to this data. Okay, so there's some things like some statements I can say about this data. What's an overall conclusion? Now, you might draw a different overall conclusion, and there's also a whole lot of background information that we don't really know. Were there incentives to move to these cities? Was it cheaper to live in those cities? Why are people moving to those cities, etc.? We don't know that. We're just looking at this data. This data is just telling us how much these cities have grown, basically, since 1971. So it's not telling us all that background information. So if you wanted to get that, you'd have to do your own research. So we can say since 1980, which is about here, and as at 2017, which is at the end point, Darwin has consistently had the largest rate of growth of all Australian cities, by far. Yep, we can see this huge gap here, and definitely with all these kind of larger cities down here, or Melbourne and Sydney, I should say, it's definitely a big gap. It's close to 5 times the growth of cities like large cities like Sydney and Melbourne. Sydney and Melbourne, around about 60–50%, maybe a bit greater. This is over 250%. So we can say it's about 5 times the growth. That's my conclusion. You might reach another conclusion, but that's the conclusion I've drawn from this data. So the conclusion is kind of like a summary statement, the kind of key points, the main points, obviously using your own words of what the data is telling us. All right, let's look at a table now, and this is the NRL season for 2021, and it's round 10. So it's about halfway through the season. I think it's like 21 rounds. You'll have a similar table to this in your work for today. So I'm going to go through how to read it. So here I've got the position, which is, which team is coming first. This is what we call the NRL ladder. Now I've only included the top 8 teams because there's quite a lot of teams. It tells me the team. It tells me how many matches they've played. So I can look down here. All of these teams have played 10 matches. Then it's got points. So they award points based on wins and losses and draws. And I can see here that the Panthers has the greatest number of points, followed by the Eels. So Panthers at 20, Eels at 18. Then I keep going across and looking at all my different columns. Now there's quite a lot of columns. I've got wins, draws, losses, buys, which means you don't have to play for that week. These are points scored for the team and points scored against the team. Then this thing here is the difference. This tells me what the difference between these two numbers is. I could calculate that myself, but this does it for me, so it's nice and easy. It tells me how many games they've played home. So they've played 6 home games. Oh, actually, sorry, how many games they've won at home. So they've won 6 home games, and they've won all their away games, and they've played 4 away games. This tells me what they're playing next, and the form, I think this basically says that they win each of their games 5–0. Probably could put that as like 10–0, but I'm not too sure why it's 5–0. Maybe, anyway. I think that's a ratio. So basically this tells us that they're kind of undefeated. They've got 0 losses. So what does this data tell me? Well, it tells me that the Panthers are, at this point in the competition, the #1 team. But I can also go through this data and kind of look at some of the other teams. So here I can go down the points. I can see, well, actually Dragons and Sea Eagles have the same number of points. So they have the same number of wins and the same number of losses. So they're very close, these two teams. They also have very similar number of points scored for the team and points scored against the team. Here it tells me the wins at home and the losses at home, and the wins away and the losses away. So they actually had more wins when they're away. This is for the Dragons, which is the opposite of the Sea Eagles. Sea Eagles had more wins at home and less wins away. But again, this is pretty early on in the competition. They've only played 10 games. You'll have more games to analyze. So at this kind of rate, you can say, well, halfway through the season, the Panthers are undefeated. Whether this trend will continue, whether they'll be undefeated for the rest of the season. If you're looking at it at this point in time, I know the season's finished now, you could say, well, based on this data, there is a trend that the Panthers will probably win this year's NRL Grand Final because they're doing the best. This is kind of what people who are really into sports statistics, they kind of go through, look at all the various data to try to make conclusions or predictions about which team will win. And here I can look at who they're playing next. They're playing the Rabbitohs, so I might want to compare. So they're playing the Rabbitohs next. So look at the Rabbitohs team. See, well, are they more likely to win at home or away? Well, they've actually won a lot of away games, so kind of doesn't really make a difference. Here they've scored quite a lot of points. But they've also had more points scored against them. There's a greater difference there. Whereas with Panthers, they've had a lot of points scored for them, and hardly any points scored against them. That's the difference there. So lots of data, lots of information, conclusions I can draw from this data. Okay, lastly, we're going to look at this two-way column chart. I've got my columns and I've got two columns kind of put side by side, and there's different colors for them. Orange is for Brazil and blue is for Southeast Asia. Now, the heading of this chart isn't particularly helpful. This is actually a part of a journal article, and it says the trees that fall. So this is kind of like a title, but it's not really a title of saying this is a comparison of Brazil and Southeast Asia. It's more to kind of get our attention, kind of like a newspaper article title. Now it actually has a statement here. Forest destruction has declined in Brazil, but it has been increasing in Southeast Asia. So that's the conclusion that the author of this article has drawn from this data. Let's see if we can draw the same conclusion. Okay, so first up, we're going to look at the data itself to see I understand it. I'm going to look at my y-axis. So I've got deforestation, and it's recorded or measured by millions of hectares. Then on the x-axis down here, so this is my y-axis, the vertical x-axis, I've got years. And instead of having kind of gaps of 5 years like we did with the line graph with population growth, here it's just year by year. And it's starting with 2001, and the last year is 2015. Okay, so what I'm going to look is at the shape of the data first, and I can see that it kind of goes up and down over time. So let's use a different color for blue. It kind of goes up, down, sort of roughly. Then it kind of goes up here, down, up and up. So it's ended up for blue, for Southeast Asia, it's ended up higher at the end in this kind of second half. If we were to cut it in half, it's ended up higher in this half than it has in the first half. Now, on the opposite, I haven't actually got an orange marker, so I'm going to use purple for Brazil. It starts off fairly high, and then it kind of goes down the bottom here. Yep. Okay, so I can see that for Brazil, yeah, it has actually been decreasing, where with Southeast Asia, it's actually been increasing over time. Now I'm going to rub these out, hopefully nice and quickly. There we go, excellent, just to make it a bit easier to read the graph. So what are some points I can make about this data, and what conclusion can I draw? And is it going to be the same as this person, the author's conclusion? So I can say that in 2002, deforestation in Brazil was greater than twice that of Southeast Asia. So not quite in 2001, but in 2002, Southeast Asia is about 1.1 maybe, whereas in Brazil, it's definitely almost like 2.5 or 2.6. So it's definitely double or greater than double of Southeast Asia. Deforestation in Brazil peaked. That means it got to its highest point in this time series in 2004. So it peaked here, and it peaked at 3 million hectares per year. And in Southeast Asia, it peaked in 2012, which is all the way down here, 8 years later. In 2007, Southeast Asia overtook Brazil in deforestation per million hectares per year. So 2007, all these years before, Brazil is doing more, even in 2006 just slightly, and then in 2007 we have a change. This is kind of the change. We can see that Southeast Asia overtakes Brazil in 2007, and then for each of the years following that. So 2008, 2009, etc. So that's kind of the turning point in this data. So my conclusion is, since 2007, Southeast Asia has experienced greater deforestation per year than Brazil. And that this data shows us. And so it's pretty much similar to this statement, just a little bit more specific. So some of the main ideas from today's lesson, it's all been about interpreting graphs and tables. So when we're interpreting, we're making sense or trying to understand what it's telling us or what information we can get from it. So firstly, when we're interpreting graphs, the thing we need to do at the very beginning is to check or read the title. particularly if you have a lot of different data displays in front of you, you want to make sure you're reading the one that will give you the right information, the information you're looking for. But also, if you don't have a whole lot of data displays in front of you, you just want to know what it's about. The title should tell you what it's about. Then you can look at the y-axis and the x-axis. Now I prefer to look at the y-axis first, just for some reason, but make sure you look at both of them and that you understand both of them. How is the data being measured? For example, with our deforestation one, it was being measured on the y-axis was millions of hectares, and then the x-axis was over time, and that was year by year. Then you want to look at the shape of the data. So is it straight or does it fluctuate? So when I mean straight, for example, here we've got some sales data. So this is the number of sales and this is the number of months, or it's not the number of months, that's the name of the months. We can see that this is relatively straight. Compared to the data at the top here, it fluctuates. It goes up and down, up and down. So it's really kind of volatile. It fluctuates and goes up and down. So that's another thing we want to look at. Is it a kind of consistent story over time, or does it vary a lot? Then we want to look at trends. So this one, the trend might be that it fluctuates. This top one here, that it goes up and down. And it seems to kind of go up and down. What are the time periods here? This is like week by week. So it seems to go down in the middle of the week and then go back up at the end of the week. This one here, over time, the trend is linear. It's a straight line, so it increases over time. Lastly, always look for the greatest difference and also look for similarities. So think about with our capital cities, we look for the greatest difference between the cities, but then we also looked at what was similar. And lastly, not lastly, I should say, we're looking at interpreting tables. It's pretty similar to graphs. It's a little bit easier. You just need to read the title, look at the column and row headings, and again, look for differences and similarities. Now, lastly, the trickiest part that we looked at today, and this takes a fair bit of practice. So really, it's just an introduction to it today. So don't stress if you don't get it. A lot of your work today will be just answering questions, but you might have a question in there saying, summarize this data, or what's the main thing this data tells us? And that's our conclusion. What's the main thing that, let's say, this sales data tells us? Well, it can say that from January to December, sales increased at a regular rate. It didn't go down. Whereas this one here, this is how much this company is worth, ABC Corporation, it fluctuates week to week. That's the main thing the data tells us there. So it's really just overall, what's the overall picture that the data is telling us. All right, guys, thanks for listening today. I'll see you tomorrow for lesson 2. Bye-bye. Welcome back, everybody. This is lesson 2 for Year 6 Maths on a Tuesday. We're looking at interpreting secondary data again today. So this is a part 2 with a slightly different focus. Okay, so today, again, you're going to be interpreting different data displays. So that's graphs and tables that I found in the media and in factual texts. Now today, slightly different to yesterday, I'd like you to identify the source of the data. So I kind of looked at that yesterday a little bit, but today, particularly with your questions, you'll need to identify where does this data come from? And any good data should tell you its source. It might either be on the graph or it might be written underneath it. Then the next thing I'd like you to focus on is reading any notes that explain the data. Now this can have a really big effect on what the data actually means. It's really about reading the fine print. Sometimes the notes will explain either where the data's come from or how they've calculated the data, or it might be a kind of a condition on the data. So it might be how reliable it is, or it excludes this kind of information, which we'll look at in a moment. And lastly, we're writing a conclusion which describes the main thing the data tells us. Now, this is all about interpreting or reading data, reading information. When we're interpreting, different people have different interpretations. They see different things, or they have a different understanding of what's going on with the data, and that's perfectly fine. Just like anything, if you have an opinion or a view, or making a statement, you just need to have evidence to back that up. And many people see data differently. They might have different interpretations. And depending on what they're trying to get out of the data or what they're trying to show, their interpretations may differ. Okay, similar to yesterday, I'm going to go through a few different examples of the data and showing you how I would look at it, break it down, and then interpret it, or come up with some statements or a conclusion about the data. So first thing I'm going to do, as always, I'm going to read the heading. So here it says, top selling Nintendo Switch games worldwide as of March 2021. And these figures are in millions of units. So that's saying basically the units are, one unit is one game. So we're talking about millions of games. Now this isn't a column chart, it's actually called a bar chart. Works very much the same way, except that these bars, when there'll be columns that are vertical, they're horizontal. So it works the same way. On my left-hand side, on this y-axis, I've got the titles or the names of the games. So Mario Kart, Animal Crossing, Pokemon, etc. And then down the bottom here, I've got my x-axis. And it starts from 0, 5, 10, so it goes up by 5s. And we're talking about millions here. Now, I don't really even need this x-axis down the bottom. It's nice that they've provided it. But here I can see they've actually given us data labels. So this is 35.39 million, 32.63 million. So we're talking about millions here. Okay, so I understand this data. It's comparing which are the top selling games, and then it's kind of ranking them. So the top selling ones are at the top, like number 1 is Mario Kart 8, number 2 is Animal Crossing, and then down the bottom, number 10 is New Super Mario Brothers. Okay, I've done that. Now, before I even go on to start thinking about what statements I can make about this, I'm going to think about what's the source of this data? Where has it come from? Well, thankfully, I've got this notes section down here, and it says data sourced from Nintendo earnings report, Q3 20 to 21. So that's a financial quarter in that financial year, and it's produced by Nintendo. It's an earnings report. Now, I'd say that's a relatively reliable source of information because Nintendo, they have to be transparent. They have to make sure they're providing their investors with reliable information. So that's the source of information. So I'm going to say this is pretty reliable information. There's another note, however. So I've got note 1 and note 2. This counts downloads and physical copies. So now you can download games onto a device, whereas in the past you just had to have a cartridge or a DVD. So it counts the physical copies that are sold in a store or online, but then also any downloads of the game as well. Okay, so now I understand this data. What statements can I make about it? Well, firstly, as at March 2021, Mario Kart 8 was the top selling Switch game with 35 million units. Now I'm just going to round it up to make it easier. Closely followed by Animal Crossing. Now you might think, well, 3 million is quite a big difference. But when we look at the other games, it's actually it's the closest game to Mario Kart 8. And our next closest game is Super Smash Brothers. That's down at 23 million. So I think it's fair to say it's relatively closely followed by Animal Crossing. Another statement I can say is half of the top 10 Switch games were Mario games. Now here I've gone through Mario Kart, I've got Super Smash Brothers. Now the brothers there refers to the Mario brothers, Luigi and Mario. I know there's a whole cast of other characters in that game, but I'm going to include that as a Mario game as well. I've got Super Mario Odyssey, Super Mario Party, and New Super Mario Brothers. So we can say fairly that half of the top 10 Switch games were Mario games. So that might tell us something a bit about the popularity of Mario as a franchise. Combined, they have a sales of 105 million units. So if I was to combine all of these top 10 games, they would have a combined sale of 105 million units. I could have maybe framed that a little bit better because someone might just talk about, I think I'm talking about Mario games. But for all of these games, we're talking about 105 million units, which is quite a lot. Now, my conclusion. I'm going to say just a general conclusion. Mario games continue to perform well for Nintendo. And I can say that because I know Mario has been around for a good 30 plus years, and there's been many different Mario games. And obviously, as at 2021, Mario is still quite a popular character, it's still quite a popular title. And so Nintendo obviously making these games and people are buying them. Now we can see here there's 5 Mario games. there's probably more games than there are, Pokemon games for the Switch or Zelda games for the Switch. So maybe it does have a slight advantage, but they're still quite popular. So that's my conclusion. You might reach a different conclusion there. But, and also depends on the situation that somebody finds themselves in. So, for example, if I worked for Nintendo and I was in charge of, what games are we going to put out? Well, I could reach this conclusion. I say, well, do you know what? Maybe we'll make some more Mario games because they continue to perform well for us. They're making us money, so why not just churn out some more? Okay, that's our first chart. Let's look at another one. Okay, here we have another gaming set of data, and this is mobile gaming revenue in China between 2011 and 2020. So revenue refers to how much money has been earned, and this is how much money has been earned by mobile games for mobile phones or smartphones in this time period, 2011 to 2020. Now, this is an interesting data display because it actually has a column graph element with the green columns, but it also has a line graph element here, which is percentage of growth. So down at the bottom here, I'm going to check my legend or my key. So the green refers to mobile gaming revenue in billions of yuan. Yuan is the currency of China. So it's talking about, how many yuan have, in terms of how many sales in yuan have there been in each of these years. This blue line is talking about percentage growth. So compared to the previous year, so example for 2011, between 2011 and 2012, what was the percentage growth between those 2 years? Okay, so I've looked at my heading, I've looked at understanding this data. This doesn't actually have a y-axis, a vertical one, but I can see here I've got all the data labels, so I don't really need to refer to that. And I can also suspect that this is in proportion as well. So it's going to give you an accurate picture. Now I'm going to look at the notes, because remember today we're looking at notes and sources. Actually, I'll look at the source first. Source. The data are calculated based on the financial results published by enterprises and interviews with experts. So it's a bit of a combination of data. It's from financial results, maybe from annual reports or earnings reports, and then also interviews with experts. So it might not be 100% accurate, but it's probably reasonably accurate. Note, China's mobile gaming revenue refers to the total users spending on mobile games in mainland China and revenue from overseas gamers. So this is revenue that's from its domestic market, so people in China who are paying for these games, but also people around the world who are paying for these Chinese-made mobile games. Okay, now I understand this data and I know where it's from, and I have just kind of checked the notes. I'm going to see what statements I can make about it. So I know this blue line is all about growth, so I'm going to focus on that. I could focus just on, dollar amounts or yuan amounts, I should say. But let's have a look at what statements we've come up with. Okay, so between 2012 and 2015, mobile gaming revenue in China increased by 34.5 percentage points. Now, I looked at the shape of this line and I can see it starts off here pretty steady, but it grows up here. So this is a period of each year it's grown, but this is a period of kind of accelerated growth or larger growth. So here it's between 40.6 and 103.7. There's a difference of 34.5. So I can see it's increased by 30.5 percentage points between 2012 and 2015. That's a period of growth, of larger growth than normal. Mobile gaming revenue in China has increased every year since 2011. So all of these figures here, the blue line, even though it dips down here, it's still a positive amount. So even though it's not as growing as much, let's say in 2017 as it did in 2015, it's still growing. It still grew by 45.6%, which is quite a lot. So it's continued to grow throughout this period. Some years less growth than others, but every year it's growing. By 2020, Chinese mobile games had an annual revenue of 264 billion yuan. Now this, remember down here, this is billion yuan, BN yuan. And I've looked at the 2020 amount because I thought, well, where are we now at the moment? So I'm not looking at the trend now or the growth. I'm just looking at how much money in the 2020 year was made of these Chinese mobile games. And that equates to $56 billion Australian. So I've actually gone through and done a conversion separately because I don't really understand yuan. And we're talking about 56 billion Australian dollars. That's a huge, eye-watering amount. So that it's made a lot of money. Okay, this is my conclusion now. So growth in mobile gaming revenue in China peaked in 2015 at 103.7%, and it's declined to its lowest ever growth since 2011 at 14%. So over this period, even though it's had growth every year and it had this really massive growth, like doubling in 2015, its growth has kind of slowed down. So it's still making money, it's still growing, but the rate of growth has slowed down. So that might be something that perhaps if you're investing in Chinese mobile games or a gaming company, you might want to know this data. That's my focus. You might have a different interpretation. There's a whole lot of different things we can look at here, but that's the main conclusion I drew there. So that even though it peaked in 2015 and still growing, the growth has started to decline. Okay, lastly, we're going to look at a table. Now, this isn't to do with gaming. This is to do with the gender composition of domestic enrollments by fields of study in 2007 to 2017. So it's looking at the difference between these 2 years. So it's talking about how many females are enrolled in a university course compared to how many males, because some fields of study or some courses, they tend to have more women in them and others tend to have more men in them. So the ones that have a lot more women are called female dominated, and the ones that have a lot more men are male dominated. Then we have this other category here, which is mixed. So already I'm looking at the data, trying to make sense of it. I've got these headings here. So this is, whether it's male or female dominant, it's called dominance in 2017. This is the name of the course or field of study. This is the percentage of females in the course and percentage of males. And this one here is the most important one. It's the change between 2007 and 2017. And it's by percentage points. Now this data is from a website that is all to do with gender equity and looking at trying to improve female participation in certain fields. So it's looking at what's the change in percentage points between 2017 and 2007 in terms of female participation in that course or female enrollment in that course. Okay, now before I even go into trying to analyze this data and come up with some statements, because this is quite complex and there's a lot to look at, I'm going to look at the source. Now always read the fine print down the bottom here. Now your sources will hopefully not be so difficult to find, but this one says source. It's from the Department of Education and Training, and this is WA data, so it's the WA or Western Australia department. And another thing here, it doesn't actually say notes, but it says agency calculations. Totals include fields of study. So some of them aren't shown. Fields not shown are food, hospitality, and personal services. So that one's not included. Mixed field programs and non-award courses are also not shown. Lastly, the gender composition calculations, that's these percentages, exclude genders other than male and female. So there are more than 2 genders, male and female. Sometimes people call that other. So it just excludes those from the calculations, because at the end of the day, we're just comparing these 2 larger groups, which are male and female. Okay, now, if you are looking at this data and someone said, okay, can you just tell me what the difference between 2007 and 2017 was for creative arts, then you'd go down this column here, go to creative arts, and you'd see, well, do you know what? The difference was actually there were less females enrolled compared as a percentage compared to 2007, and it was a difference of 2.4 percentage points. So it was a decrease of 2.4 percentage points. If that's all you're looking at for this data, that's all you'd find. That's all you need to do. If you wanted to kind of generalize the data or make a statement about it or a conclusion, you really need to look for the things that you think are the most interesting or the most important. So statements. Now, these are what I've come up with. You might come up with something different. You won't have one to look at like this today. This is just an example. So I've said, I've kind of split it up into female dominated, mixed, and male dominated because the table split up that way. So in female dominated fields, male enrollments as a percentage were up slightly from 2007. Because if it goes negative for female, then it's obviously gone up for males, except for in society and culture. So there were more women doing society and culture as a percentage in 2017 than in 2007. In mixed fields, female enrollments only went up for agriculture. That's this one here. So it went up by 2.4 percentage points, but it went down for all the other ones. Now I go down to male dominated. Proportionally more female were enrolled in engineering than 2007. Engineering's here, 1.5, but less in IT, which was down by 1.8 percentage points. Now you could really go through this and look at all the numbers and stuff. These are just some of the main things I've found. And my conclusion is, the greatest changes in female enrollments were in agriculture, which was up 2.4 percentage points, and down 2.4 percentage points in creative arts. They're the ones we're really interested in. All these other ones, they're pretty small changes. That not really a lot has changed in 10 years' time. So I just said no large changes overall. That's my overall conclusion of this. So maybe this organization or department, they need to do a bit more research into how they can improve female enrollment in some of these courses, but also how they can improve male enrollment in some of these courses as well. For example, in society and culture. Okay, so the main ideas from today's lesson, a little bit shorter, is make sure you check the source of the data. It's really, we'll kind of look at that more so on Wednesday and Thursday, but it's really important you know where your data is coming from. It tells you how reliable it is, but as we'll look at on Wednesday and Thursday, it can also tell you whether there's a bias in the data, whether it's really trying to promote a message, trying to get you to believe something or try to persuade you of something. Make sure you read any explanatory notes. It can really change what the data means. For example, in that last example, it excluded certain courses. With the Nintendo example, if it didn't include downloads, then it'll be telling maybe a very different story and not showing the full picture. But because it included downloads and physical games, it's actually a fairly complete picture. Your interpretation of the data may differ to someone else's. You might be looking at different things. You might reach a different conclusion. And lastly, where you've got a whole lot of data in front of you, just decide on the most important things to talk about. That's really, what are the main messages, the main things this data is telling you? You could go through and say something about everything in that graph, but you really want to look at the biggest changes and the smallest changes. Or if there's a whole lot of similarities, look at those similarities. What's the same? Okay, guys, thank you very much for listening today. I look forward to talking to you for Wednesday and Thursday. See you then. Okay, we're halfway through our data unit for this week. This is Wednesday for Year 6, Lesson 3. Today, it's all about messages in data. What is the person who's creating, or the company who's creating the data and showing it to us? Are they trying to give us a message? Are they trying to tell us something? Okay, so in today's lesson and for tomorrow as well, we're going to be using our critical evaluation skills. We're critically evaluating different data displays. Now, you might be asking, what do you mean by critically evaluating? Well, let's look at this word evaluate. When you are evaluating something, you're making a judgment about it. You're thinking about how important is it? how reliable is it? Is it a quality product or is it not a quality product? And when you're doing that critically, you're asking questions. You're really thinking about it. Okay, can I actually rely on this? Is it misleading? Is it trying to tell me something? It's really thinking about not just accepting it, but going, well, wait a second, what's actually going on here? Why did somebody create this data and why am I seeing it? What are they trying to convince me of? Or what are they trying to tell me? It's really about asking questions. To do this, we need to firstly identify the source of the data. Where does it come from? Once you've identified the source, you can maybe have a better idea of why you're seeing this data, how reliable it is, and whoever created it, what they're trying to tell you. We're also going to be looking at a possible bias in the data. Is the way the data is displayed or the way that it's given a title, is it trying to make us think one way? Is it trying to focus our attention on something? Is there a reason for that? For example, with a company doesn't want to make itself look bad. It wants to make itself look good. It wants to make itself look successful, attractive, like it provides a quality product or a service. So it wants to show its best self to its customers. So when it's presenting data, it's probably going to have a possible bias there that they're going to show the good stuff and not so much show the bad stuff. We're also going to look at identifying messages that data displays are trying to tell us. So what's the overall message in the data that whoever created the data display is trying to tell us, and can we rely on that? And the most important thing, this is all about critical thinking, it's just about asking questions, thinking about all that background stuff. Who made this? Why did they make this? Why are some things missing? Why are some things shown the way they're shown? So we're going to go through a few examples. I'm going to show how I question the data and sort of how I'd like you to do it today as well in your activities. Okay, so thinking critically. All right, now here we've got a data display, but it's also an advertisement about KFC's crispy chicken twister. And KFC here, they've put together a bar chart, so it's like a horizontal column graph. And they're comparing what I imagine this is Pizza Hut or Domino's, McDonald's, KFC, Taco Bell, Burger King, and Wendy's. Now, this is an American display because we don't have Wendy's here, or I don't think we have got Taco Bell either. And we call Burger King Hungry Jacks anyway. What it's comparing is it's looking at calories in its crispy chicken twister, and it's comparing it to what I imagine are the same or similar products in these other fast food chains. Now it's saying, well, actually, KFC on a calorie basis, KFC is 650, and it's actually less than if you were to get a chicken twister at Wendy's or at Burger King or at Taco Bell. So it's trying to convince us that, KFC chicken twisters compared to these other companies are actually pretty healthy. So here are some questions I'm going to ask. Firstly, why is KFC showing me this? Well, the obvious response to that is probably, well, why are crispy chicken twisters? They are healthy. It's trying to get me to buy something. So that's why they're showing me this data and trying to convince me to buy this product, this chicken twister. What is it trying to tell me? Well, it's trying to tell me that it's relatively healthy compared to these other ones here. Maybe not as healthy as Pizza Hut and McDonald's, but it's still healthier than these other three brands, so it's pretty healthy. Now, here's a question I'm going to ask. Why does the chart start at 590 calories and not at 0? So normally with a chart of any kind, we'd start at 0 on the x-axis, or if for this one, or 0 on the y-axis. This point of origin is 0, and it goes up to however big it is. Now, I'm going to say the reason why they're starting at 590 and not at 0 is because this difference here looks bigger when we start at 590 and go up to 730. If I started at 0 and went all the way up to 730, the difference wouldn't look as big. It'd probably be about maybe here or so. probably about there, it wouldn't look as big. So they're trying to make the difference look bigger than it would on another data display. So again, trying to convince me. Another question I want to ask is, well, is 650 calories a healthy amount of energy for somebody to consume in a single, item of food? Even though we're talking about, calories here and it's healthier than these other products, these might be super unhealthy as well. These might all be unhealthy. So even though they're trying to say it's a healthy product, this doesn't actually tell me it's healthy. The other thing that is quite interesting to ask is, where have they got this data from? Is this from their own research? Is this from research from somewhere else? How have they come up with these calorie figures? And lastly, the other thing that they don't talk about is, well, how do these other products compare in size or in quality? Are these Taco Bell, Burger King, and Wendy's, are they twice the size of the KFC Twister? Are these ones down here, much smaller? It doesn't actually tell me anything about these products apart from the calorie value, but we don't know whether it's the same size or larger or it's tastier. It's really just this kind of idea that, KFC is good because it's only $6.50, but there might be a good reason why these other products are actually $7.20. So that's what I mean about thinking critically about a data display. There's a whole lot of other questions we can ask about data that's presented to us, particularly thinking about what is the motivation for the person showing me this data? Why are they showing me this data and what are they trying to tell me? Okay, here we have another data display, and this is from the Coca-Cola Company World Without Waste 2019 Progress Report. So here it's showing the collection rates of different types of packaging the Coca-Cola Company uses for its products, mostly drinks, I'd imagine. So here I've got aluminium and steel cans, we've got PET plastic bottles, non-refillable glass bottles, and so on. Now, instead of just showing us on a column graph, what they've decided to do here is draw pictures of each of the different products, and then for the percentage that's collected of that product, they've shaved that same amount. So here, this is 64.9%. Apologies for how small the font is. I didn't design this. 64.9% of this can is shaded green. 55% of this bottle is shaded green as well. It's a little bit tricky. Ideally, you'd like to have the same size bars or columns to be able to easily compare between the products. They haven't done that. I wouldn't say this is misleading though, because it does give you the percentage, so you can easily just compare the percentage. And I think the idea is to make it look more attractive for the reader, so they go, that's an innovative way of showing the data, but also a bit more interested in the data. Okay, so and the source, I know, yep, I've said it's from the report. So the first thing I'm going to ask myself is, why is the Coca-Cola Company showing me this? What are they trying to tell me? Well, it's in this World Without Waste report, which is about how much waste the Coca-Cola Company produces as a corporate company making products. So maybe they're trying to tell me that they're doing something about the waste they're created. What is it trying to tell me? Pretty much similar, that they're trying to do something about all the waste that they produce and all the containers they produce, but also maybe that Coca-Cola is an environmentally responsible company, that they are doing something about it and they're making progress and they're tracking it. And every year they do this report. So maybe that's what the message is that they're trying to tell me. They're trying to convince me that Coca-Cola cares about the environment. Okay, so those are the two main questions I want to ask. Now I'm going to ask a few other questions about this. So firstly, how many of each of these packaging does Coca-Cola make in a year? So yeah, we talked about 64% of cans end up being collected, but how many cans are we actually talking about? We're talking about billions of cans. For here, we're talking about pouches. How many pouches do they make in a year? They only collected 8.6%. How many end up in landfill or end up in the environment? So it doesn't tell me how many they make in a year. Now, there's probably a good reason for that, because the numbers are so large that it's hard for people to comprehend, but it doesn't tell me that information. Maybe they're hiding it for some reason. What happens to the packaging that doesn't get collected? So this seems like, oh, everything's going well, we're collecting more packaging. What happens to this kind of dark part here that's not being collected? Is it ending up in landfill? Is it ending up in the environment, in the ocean? What impact is that having on marine life, on other animals? Just how serious is this problem of waste, of corporate waste? This question I kind of almost overlooked, but does all the collected packaging get recycled? So they might be collecting this packaging, but are they just putting it into landfill, or are they recycling all of it? What's the proportion that's getting recycled? Can they even all be recycled? How does this compare to other companies? So this is one company that makes soft drinks. There are other companies. Is Coca-Cola a leader in this area, or are they behind other companies in taking responsibility for their actions and being environmentally responsible? And lastly, why does it not show data from before 2018? So this is the 2019 data, and it also tells me overall it was 56%. What about all those years before? Has this just ramped up in the last 2 years? Has this actually gotten worse in the last couple of years? We don't actually know. So it's not telling me the historical data. Now, it might not be relevant, but that's a question I can ask myself. What happened in the 10 years before this? Was it all just going into the landfill and the environment? So again, the main thing I want to see is, what's the message that they're trying to tell me here is that Coca-Cola is environmentally responsible, but there's all these other questions that data doesn't show me. And they might be trying to hide stuff, or it just might not be relevant. Now, the last graph I'm going to show you is from the newspaper, The Guardian. Originally, it was an English newspaper, but now it has branches worldwide in Australia and the US. And it's also from 2009. So it looks at data between 2010 and 2009, and it's in an article published in the paper in 2009. So it's quite old. Here I can see I've got my various newspapers in the UK. So the Sun, the Daily Mirror, blah, 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 and they've all got different colors. And you can see for most of them, they're either declining quite quickly, like the orange one, which is Daily Mirror, or they're kind of declining slowly, like the Guardian or the Independent. It also has this subheading here, or byline: fall in print sales cannot be attributed to a single reason, but the fragmentation of society and media have contributed. Okay, so firstly, why is The Guardian showing me this? Well, The Guardian itself is a newspaper. So maybe it's trying to say, well, we're in danger and we need your support. We need you to buy our newspaper. Otherwise, newspaper sales will keep on declining and we might not be able to bring you the news because we're not earning enough money. Might also have other reasons. The Guardian itself is quite a socially conscious paper. So here they're talking about the fragmentation of society and media. So rather than trying to get us to buy more papers, they might trying to get us to be concerned about how society is becoming more divided and how media is becoming more divided. What is it trying to tell me? Well, it tells me that newspaper sales have plunged, and this is the reason: the fragmentation of society and media. There's no single reason. All right, so they're my two main questions. Now just a few kind of critical questions. How many people read the online versions of these papers? So we know that starting in the kind of mid to late 90s, people started using the internet more. So while these newspaper sales, this is the paper version, it's declining, maybe the online version is increasing. Maybe more people are just reading it online, either on their phones or on a laptop. So 2008, 2009, roughly when smartphones kind of came into being and became really popular, maybe more people were just reading on their smartphone. What happened in the 10 years before that? Was it always declining, or was it pretty steady, or was it increasing in the 90s? Who knows? And lastly, how did they reach this conclusion about the fragmentation of society and media? Is this journalist, is this author trying to push a story or trying to convince me of the way he sees the world, or do they actually have some data about that they're not showing here? So again, this is kind of an opinion piece in a newspaper. It's trying to convince me of an opinion, and it's trying to do that using data. So today, it's all been about thinking critically about data. Now, when I say critically, that's not being dismissive or looking at it negatively. It's actually thinking about, what's going on behind the scenes. And to do that, you ask some questions. Now, today, we really ask these two main questions. The first one is, why am I being shown this data? What is the motivation behind it? What is the person who's created the data or showing it trying to do? Is there a profit motivation, like with the KFC Twister one, where they're trying to get us to buy it because it seems healthy? Is there an image motivation, like with the Coca-Cola example, trying to promote themselves as being environmentally responsible? Or is there an opinion that's trying to be put upon us, like with a newspaper example, where that journalist was saying, well, newspapers are declining in terms of people buying the paper newspapers, and that's because society is, getting more fragmented. There's all these issues in society. So that's his opinion. He's trying to promote that using the data. Secondly, we ask, what is the maker of the data trying to tell me? What's the overall message? Now, sometimes you won't be given a sentence describing the message. Sometimes it will be in the heading, like that last example, where it actually told us what was going on in the data. So you'll have a few different examples today. Sometimes it might be in the heading. Other times you'll need to infer, you'll need to make an inference based on what you know. The two main things you need to do, firstly, is to identify the source of the data. So where has it come from? Because that'll help us answer some of these questions. And then think about potential or possible bias there. So a company that's making data or presenting data, what might be a bias there? Are they really going to show data that makes themselves look bad? Same with a journalist, for example. Are they really going to show data that goes against their opinion? Probably not. They're probably going to try to find data that reinforces or supports their opinions. So that's a bias there. Okay, guys, thanks for listening today. Tomorrow we get into really interesting territory where we'll look at the dark arts of misleading data. All right, see you then. Okay, welcome back, everybody. This is lesson 4 for Year 6 Maths for data, your last lesson for the week on a Thursday. This week we've been looking at interpreting or making sense of data and trying to see what story it tells. Then yesterday we thought about data quite critically and thinking about what are the motivations behind data being shown in different ways. Why, what kind of story is the person who's put together the data and presented it in a certain way? What story are they trying to tell? What are they trying to get us to feel or trying to get us to think or trying to get us to do? That's thinking critically about it. Today, we enter a really interesting territory of misleading data. This is where data has been displayed in a way that misleads the reader to think one thing, when in fact, that's not actually the case in reality. Sometimes it can be done because the person who's put together the data doesn't know how to display data properly, or in a lot of cases, it's actually done deliberately to really try to be sneaky and mislead people. So let's look at some examples. Now, firstly, this is our learning intention for today, is just to identify how data displays can be misleading. Now, there's several different ways they can be misleading, and we're going to go through how to spot situations where a data display is misleading. So today, you're going to identify ways that data can be displayed to mislead readers. Now, to start off first, we're going to watch a TED Talks video, which goes through about 5 minutes long, and it uses different examples of showing really common ways that data can be misleading.
A toothpaste brand claims their product will destroy more plaque than any product ever made. A politician tells you their plan will create the most jobs. We're so used to hearing these kinds of exaggerations in advertising and politics that we might not even bat an eye. But what about when the claim is accompanied by a graph? After all, a graph isn't an opinion. It represents cold, hard numbers, and who can argue with those? Yet, as it turns out, there are plenty of ways graphs can mislead and outright manipulate. Here are some things to look out for. In this 1992 ad, Chevy claimed to make the most reliable trucks in America using this graph. Not only does it show that 98% of all Chevy trucks sold in the last 10 years are still on the road, but it looks like they're twice as dependable as Toyota trucks. That is, until you take a closer look at the numbers on the left and see that the figure for Toyota is about 96.5%. The scale only goes between 95 and 100%. If it went from 0 to 100, it would look like this. This is one of the most common ways graphs misrepresent data, by distorting the scale. Zooming in on a small portion of the y-axis exaggerates a barely detectable difference between the things being compared. And it's especially misleading with bar graphs, since we assume the difference in the size of the bars is proportional to the values. But the scale can also be distorted along the x-axis, usually in line graphs showing something changing over time. This chart showing the rise in American unemployment from 2008 to 2010 manipulates the x-axis in two ways. First of all, the scale is inconsistent, compressing the 15th-month span after March 2009 to look shorter than the preceding 6 months. Using more consistent data points gives a different picture, with job losses tapering off by the end of 2009. And if you wonder why they were increasing in the first place, the timeline starts immediately after the US's biggest financial collapse since the Great Depression. These techniques are known as cherry picking. A time range can be carefully chosen to exclude the impact of a major event right outside it. And picking specific data points can hide important changes in between. Even when there's nothing wrong with the graph itself, leaving out relevant data can give a misleading impression. This chart of how many people watch the Super Bowl each year makes it look like the event's popularity is exploding. But it's not accounting for population growth. The ratings have actually held steady because while the number of football fans has increased, their share of overall viewership has not. Finally, a graph can't tell you much if you don't know the full significance of what's being presented. Both of the following graphs use the same ocean temperature data from the National Centers for Environmental Information. So why do they seem to give opposite impressions? The first graph plots the average annual ocean temperature from 1880 to 2016, making the change look insignificant. But in fact, a rise of even half a degree Celsius can cause massive ecological disruption. This is why the second graph, which shows the average temperature variation each year, is far more significant. When they're used well, graphs can help us intuitively grasp complex data. But as visual software has enabled more usage of graphs throughout all media, it's also made them easier to use in a careless or dishonest way. So the next time you see a graph, don't be swayed by the lines and curves. Look at the labels, the numbers, the scale, and the context, and ask what story the picture is trying to tell.
In the video you just watched, you saw some of the different ways that data displays can be manipulated to kind of reinforce or mislead a point of view. Now, I'll just go through some of those quite quickly. The first one is what's called omitting the baseline. So here, this was with the Ford Chevy example. Here, this one looks like there's a huge difference between group A, B, and C. But when we look at the y-axis, we notice that it's only 50 to 62.5. Whereas if we put this onto starting from 0 up to 80%, then the differences don't look so big. Yeah, we've got the numbers there, and there is a difference, but the difference isn't that significant. Another way is manipulating the y-axis as well. So here we've got 10, 20, 30, and 40, which seems quite reasonable. It's going up by tens, and it's in a scale. And here we've got the years. All of the years have been included, so none of the years are missing. But what's happened with this graph is we actually have all this space up the top. So it's kind of been dampened or flattened. We've got all this white space. Whereas a better graph would probably show, use a smaller scale, so use 5, 10, 15, so going up by fives. And it actually shows, well, there has been a fair bit of change year to year. It's gone up by approximately 5 here, then down by 2, and so on. Whereas here, it really looks like there's not much change at all. It looks quite flat. Number 3 is cherry picking data. That's choosing the data you want to show and kind of not showing the rest of it to give a favorable impression of what's going on. So here we've got a misleading example because it only shows the months in the year 2020 and only between May and August. So everything looks like it's going up. But when we look at the broader picture, the bigger picture with the years surrounding 2020, we can actually see that things get worse after August, and it starts to go down quite significantly. So this one's more accurate, whereas this one here is misleading. It's only showing us the good stuff. Another way to mislead, which wasn't covered in the video, is to use the wrong type of graph. So here we've got a pie chart or a section chart or a section graph, whatever you want to call it. And we've got 50%, 64, 38. Now with a pie chart, it has to add up to 100% because you can only have 100% as a whole. And so the total that these can add up to is 100%, whereas these numbers 64, 50, and 38 are greater than 100%. So that doesn't work. Now we want to keep these numbers 64, 50, and 38. So a better way to show them, a more accurate way to show them, would be to use a column graph like this one here. Another example that wasn't covered in the videos is what's called going against conventions. So you think about conventions, red generally means stop and green means go, or red when we're talking about money usually means, negative money like debt or losing money, and green means good. It means, getting more money, it's plus. So that's a convention. Here we've got a convention of a map of the United States. You would think that the darker parts would be more densely populated, wouldn't you? This is a population graph, whereas the lighter parts would be less populated. Whereas in fact, this is actually misleading because they put the darker color as 0 and white as the lighter part. So the convention would be the more populated a state is, the darker it should be, and the less populated per kilometer, the lighter it should be. So this is the accurate version. Okay, so let's look at a few examples of bad graph, good graph, and try to figure out how they're misleading. So here we've got a graph which shows Arkansas football wins over these various years. Why is it a bad graph? Well, it has all this space here. So what they've done is they've dampened the effect by putting all this white space in here to try to make this look like it's a flat line, that they're pretty consistent with their wins. Whereas actually they've manipulated the y-axis. So this axis here, it's too big, the scale is too big, it needs to be smaller. So a good graph would look like this, which actually shows there's a lot of variation between the years in terms of how many wins they get. Whereas here it looks like, oh, they're a consistent team in the bad graph. Whereas in the good graph, well, actually, year to year, there's quite a difference. What about this one? This is Twitter and its stock price, so how much it's worth on the stock market. Well, it's from March the 1st to May 24th in this year, I'm not too sure what this year is, everything looks like it's going great, it's going up. Well, actually, they've cherry-picked the data in this one, because if you look at the good graph, you see, well, over time from 2014 to 2017, Twitter's market price, or stock price, I should say, has actually decreased over time. So it's gotten worse. So if you were to see this and you were to buy Twitter shares on this one here, you're like, oh, it's a good investment, it keeps going up. Well, it's only gone up by a little bit down here. Over time, it's done badly, which probably goes to show, over time, it's not going to do much greater in the future. In this graph, we can see that UK national debt, so that's how much money the government owes as a percentage of its gross domestic product. Here, it looks like it's increasing. Oh my gosh, everything's really bad in the UK, it's increasing. But this is actually a misleading example because it's cherry picking data. It's only showing between 1995 and 2016, whereas if we actually saw the broader context, you could see that over here between 2015 and 1995, it's not the highest level that the UK has had national debt. If we go back to when the late 1940s or mid 1940s during World War II, it was much higher. And in the beginning part of the 20th century, it was very high. So it actually shows a very different picture. Yes, it's increasing, but it's not astronomical, and it's not something the UK government can't deal with. Here we've got a line graph of the cost of gas or petrol that's been presented by Fox News in America. And it says national average cost of petrol. And we can see that it's increasing. So it looks like it's a bad story. Everything's getting worse. But we can actually see that they've misled us by manipulating the x-axis. So here we've got last year, then last week, and then current. Now the reason why this is misleading is because between these two dates, that's 7 days. Whereas between these two, we're talking about almost 365 days. So this isn't actually an accurate line graph. They've manipulated it by kind of pushing this together closer. So this looks like it's a sharp increase, whereas in fact, it's probably a lot flatter than that. Yeah, it might have increased, but it hasn't increased so quickly. Another case from Fox News, this is about COVID cases in America. And the reason why this is a misleading graph is because it's manipulated the y-axis. Now you'd be like, well, actually there's no kind of space up here. It's not like that first Arkansas football team. But if you look carefully at the scale, we've got 30 to 60, okay? 60 to 90, so we're talking about a difference of 30. 90 to 100, well, that's a difference of 10. 100 to 30, that's a difference of 30. We've got 30, 30. 190 to 240 is 50. 240 to 250 is 10. 250 to 300 is 50. They're keeping on changing the scale here to manipulate the shape of the data to make it look higher in some points and lower in others. So they've manipulated the y-axis. Our good friend Donald Trump, this is from a few years ago. This is when he just become president and he was looking at his job approval rating. Now, if you just tuned into the news and you saw a job approval rating and you just read this headline here, and you're like, well, 88% of Americans approve of Donald Trump. And Donald Trump seems to think that's a good thing. He's like, yep, thank you very much, working really hard. But if you look carefully, this is his job approval. That's how many people think he's doing a good job among Republicans. And it's actually not even among voting Republicans. It's just people, politicians in his own party. So of course, it's hopefully going to be a high approval rating. So it's actually kind of misleading. So it's misleading by not telling us the full context. Another case, sorry, Donald Trump, another one for you. We've got Trump here with 45% of people voted for Trump in Colorado and 43% voted for Hillary Clinton. Okay, that's fine. But if we look at this, this looks like it's a huge difference between 45 and 43, particularly if you started from 0 down here. There'd actually be a lot closer on a proper graph. So this has manipulated the y-axis here. It's looking like there's a, 2% wouldn't look like this on a column graph. This case here is COVID-19 testing in the US. So it looks like every day, more and more people are getting tested. It's like, okay, on this day here on the 20th, we had this many people. and on this day, like this many people and this many people, and wow, look at this, look how many people are getting tested on this day. Whereas in fact, this is actually cumulative. So it's just adding the previous day as it goes along. So it's actually quite steady. So it looks like, whoa, it's really spiked and every day more and more people are getting tested. But really the kind of testing rate is pretty even, pretty flat. So it's misled by omitting information. It really should say this is cumulative. It's adding each day. And our last one today is looking at some advertisements. The first one is for Optus. So here we've got a map of Australia, and we've got Optus at 98.5% and Telstra at 99.3%. Now, Telstra is well known for having very good coverage, meaning that it reaches lots of different parts of Australia with its mobile coverage. So you can be out in the desert and hopefully you'll get Telstra coverage. Now, Optus has included this statistic here, this percentage. So you would think, looking at a map of Australia and 98.5%, that it would reach 98.5% of Australia's landmass. So you could be in the middle of nowhere and you'd get Optus coverage. Whereas actually, this figure is telling us how many customers or how many people Optus can reach. But we know that Australia, a lot of people live in cities. So you could be in Sydney and you can get Optus coverage. But if you're out in the countryside or out in the desert, you might not get Optus coverage. So this is telling us how many people it reaches, but not its coverage. So it's actually misleading, and Telstra sued them for it, and they were successful. Here we've got a Nurofen is better than paracetamol. Now this data is correct, but what it's not telling us is that this data is from the mid-90s, and there have actually been other studies after this which shows that Nurofen is not actually more effective than paracetamol. So this is old or dated information. So it's not accurate, it's misleading. So these two have misled by omitting or not including information. That's another way to mislead using data. All right, so just to sum up, today's lesson was all about how data can mislead people. It can mislead by manipulating the X or Y axis. So that could be not starting from zero. Now, not all things have to start from zero, but in most cases, it's a good idea to. Using the wrong scale, like where we have a lot of space to kind of flatten the shape of the data, or using a broken axis that's like not including dates or not having the kind of right scale. So for example, with that gas example where we had the year, then the last year, and then today, that's a broken axis. Cherry picking data, so just choosing the part of time or the data that's makes everything look good. Omitting information or context, that means not telling the full picture. Like for example, there was just a recession, or there's actual things you need to know about global ocean temperatures, and this is how it's measured. Using the wrong type of graph, so using a pie graph instead of a line graph or a column graph where you should. And going against conventions, so tricking people by using certain colors or certain conventions to make them think the opposite of what actually is happening. Okay, so this week has all been about your data literacy, thinking critically about data, so you're not misled as a citizen when you get older, and you can actually evaluate and think about data critically and go, well, this data either doesn't make sense, it's trying to convince me of something which it's not actually showing, or it's deliberately misleading me. Okay, what I'm going to do is I'm going to save this as a PDF as well, so you can go through and have a look at some of the examples. Hope you've enjoyed this week, and I'll talk to you soon. Bye-bye.